Hey, this is your TA Syed. I just wanted to go over a little bit about metabolic pathways with you. I encourage you guys to look over all your notes about metabolic pathways. This one's a little bit more complex, as you can see, but I want to go over something really complex like this. It's important to be able to recognize these kinds of things and be able to apply the things you learn in class to these real life situations. So this is a metabolic pathway for alcohol. When you're drinking alcohol, this is what your body does. And so I want to go over all the steps that are taking place here. So if we look at ethanol here, ethanol is just another word for alcohol, right? So that's your alcohol. And then what's happening here is it's showing the conversion of ethanol to acetate. And this is basically what your body's doing. It's turning your ethanol into acetate to take care of all the alcohol in your system. So to start, I just want to identify what you're looking at here. This might be very confusing at first. In the past, you've seen metabolic pathways with a precursor and then arginine at the end. Over here, this is very similar. It's the same stuff. It's just more complex looking. So here, basically, ethanol is the precursor. When alcohol comes into your system, that's the first thing that is going to react. And this is showing ethanol turning into acetaldehyde, which in the end is going to turn to acetate, which will go into your circulation eventually. So just focus on these three things for now, and just this line for now, basically, of all this stuff. I'm going to go over it slowly. Here we have ethanol to acetaldehyde. How is that happening? We have ADH, an enzyme ADH called alcohol dehydrogenase, turning ethanol into acetaldehyde. While this reaction occurs, we have NAD plus being converted to NADH. So this reaction doesn't occur without this happening as well. Afterwards, we have acetaldehyde being turned to acetate using this other enzyme. It's a different enzyme, ALDH2. I don't know what that is, but it's another enzyme, and it's turning acetaldehyde into acetate. At the same time, while it converts acetaldehyde to acetate, you have the conversion of NAD plus to NADH. So now that we've simplified this a little bit, I want to go into a little bit more detail. Let's say you're drinking alcohol one night and you're just like, man, I want some more. So then you go and you drink some more. Now, your body is not only going to do this whole reaction in this line with ADH and ALDH2, your body is also going to go and say, okay, I'm going to need a little bit more help. We need to get rid of this alcohol faster because this guy's drinking a ton. So now we're going to convert your alcohol using catalase. And not only are we going to do this reaction into acetaldehyde, but at the same time we're going to do the catalase reaction, where we have ethanol, the conversion of ethanol into acetaldehyde being catalyzed by catalase, and at the same time H2O2, hydrogen peroxide, being turned into water within the peroxisome of the cell. So you have all of this occurring now, all of this. So let's say you really want to drink some alcohol one night, and your body's going to say, wow, this guy's really drinking a lot of alcohol. I'm already going through this process to get the alcohol out of his system. I'm already using this catalase enzyme in my peroxisomes to get rid of the alcohol in his system. But this guy's just got a lot of alcohol in his system, and I really need to get rid of it. So what's the body going to do? So not only is it going to do this reaction and this reaction at the same time, your body is going to go and do this reaction also. What is this showing? This is a new enzyme, CYP2E1, found in the microsome. Microsome is an organelle you don't really need to worry about right now. So what's going to happen is that you have this enzyme, CYP2E1, catalyzing the reaction of ethanol into acetaldehyde. But the only way that this enzyme will work is if this also occurs. This enzyme will work to catalyze this reaction of NADPH plus H plus O2. It'll catalyze that reaction into NAD plus H2O, while at the same time catalyzing the reaction of ethanol into acetaldehyde. That's why this arrow's curvy and this arrow's curvy. This is catalyzing all this stuff going on at once, right? But if there's no NADPH in the cell within the microsome, then you can't use this. And this just isn't going to work out, because this enzyme depends upon ethanol and NADPH and H plus and O2. It depends upon all these precursors to go through this reaction and that reaction. Similarly, we have this reaction that I was talking about earlier, where catalase is catalyzing the reaction of H2O2 into H2O, and at the same time catalase is catalyzing the reaction of ethanol into acetaldehyde. So catalase will depend upon H2O2 to be there, and it'll depend upon ethanol to be there. Peroxisomes almost always have H2O2 in them, so that shouldn't really be a problem. And this is like an example, as far as I'm aware, this looks like it's an example of energy coupling, where you have the energy being released by the reaction of this into this. You have that energy being released, and we're using that to drive the reaction of this ethanol into acetaldehyde. So we talked about how when we have different levels of alcohol within our bodies, our body has the ability to cope for the addition of more ethanol, more alcohol in the system. After using this, it can also add the reaction of this, and it can also add this reaction. So what I want to ask you now, after all of this, and after reviewing your notes, this is a lot of information. I really want you guys to review your notes on metabolic pathways. But after seeing all of this, why is it that we still get drunk? In other words, why is it that we still have ethanol within our bodies when we drink? Even though we have this reaction, this reaction, this reaction, all going to make sure we don't get ethanol in our system, what are some reasons, what are some possible reasons that we still have ethanol within our circulation, going around our blood system and making us drunk? I'd like you to answer that question, and please put some thought into this. I'm not going to give extra credit points if it's not a good answer. What I did not go over in this video is how to read this table for this metabolic pathway, and how to create the metabolic pathway based on what you see in this table. It's important that you see that with the arginine, all strains of the bacteria are going to grow in the arginine. That means that the arginine has to be the final product. That's the product that everything is going to grow in. That's the product that every bacterial strain wants. And you can use that sort of logic to go from the table to the metabolic pathway.